Hey everyone, it's Mrs. Fallon. I'm going to go ahead and go through section 12.3, which is two-way tables and probability. You guys can refer back to the Big Ideas ebook if you have any or some additional questions or go through some additional examples. All right, so first I'm going to start with the definition of what a two-way table is and just kind of walk through it a little bit. So a two-way table is a frequency table that displays data collected from one source but belongs in two different categories. So for example, a lot of this is like stuff where you would like survey people and say like if you surveyed all the boys and girls in your class and you asked them do they like a block schedule versus a traditional schedule, and then you recorded your data and so forth, and you could use a two-way table to record your data. Anyways, what I'm going to do is I'm going to walk through a couple examples. The notes that I have right here, I just linked a PDF copy on our learning plan, and you're welcome to print those out, or you can just obviously just pause the video or write them on a separate sheet of paper. Okay, so the first example just says, Mrs. Fallon surveyed all current 9th and 10th graders and asked them what the class they preferred more, math or English. Of the 235 ninth graders surveyed, 145 preferred math and the rest preferred English. 190 10th graders liked math and 200 of them liked English. Make a two-way table to display your data. All right, so for this, what we're going to do is we're going to think about the two things that we're talking about. So we're talking about 9th graders and 10th graders. So I'm going to put 9th graders over here and 10th graders over here. And then we're going to also talk about, basically, we're going to ask them if they like math, which of course everybody likes math, or English. And so this is kind of how I'm going to collect my data. These are the two things that I'm referring to in my table. So like basically what grade you're in and what subject you prefer. Now let's look at all the data points. So it says, of the 235 ninth graders. All right, so this row right here is all about ninth graders. So this means there are 235 total ninth graders in my survey. So that whole row has to add up to 235. 145 of this group preferred math. So I'm going to put 145 here. So how you read this is ninth graders who like math. And if we just did some subtraction here, we would figure out that 90 of those kids also liked English. So ninth graders who liked English would be 90. These two numbers should add up to our total, which is going to be 235. All right, moving on. It says 190 10th graders liked math. So 10th graders who like math would go right here. So 190. And then we said 200 of them liked English. So 200 10th graders liked English. So what I didn't give you in this video, or what I didn't give you in this column, is the total. So you just have to add those up and get 390. So what you're going to be doing here now is these kind of rows here are going to kind of give our total. So I'm going to add all the numbers kind of going down. So 235 plus 390 gives me 625. And then if I added just the people in the math column, I would get a total of 335. And then in the English column, I get a total of 290. Also, if I added it going kind of across or horizontally, these two numbers here should add up to 625. So 625 represents basically how many people we surveyed in our entire survey. So that's like kind of our total of everything. So this is what a two-way table looks like. It's just an organization of data. Again, kind of putting your two variables, so what grade you're in and what subject you prefer, and then kind of just organizing your data. This is the data we collected, and these were just our totals from our data. So the next question asks about joint frequencies and marginal frequencies. So a joint frequency just refers to what of these, like basically of these numbers, which one of them represents joint frequencies. Well, a joint frequency is basically any of the numbers that are in the inside. So it's each entry in the table. Okay, so what that means is like 145 would be a joint frequency because it represents 9th graders who like math. Or 200 would be a joint frequency because it represents 10th graders who like English. A marginal frequency is a sum of a row or column. So we did that above. and we put that in our total. So like this number is a sum of this row. So this number right here, this marginal frequency represents 235 ninth graders in my survey. Here's another marginal frequency. That's 390 10th graders in my survey. We could also do marginal frequencies kind of going in columns. So vertically, we have 335 people in our survey who chose math and 290 who chose English. So all of the ones that I circled here are talking about marginal frequencies because they add up the joint frequencies in the column or row, and the joint frequencies are each individual number. All right, let's do some more. So this next example we're going to kind of walk through, and this is going to kind of be our last example, but there's a few different parts. So let me walk you through it a little bit. It says you randomly survey students about whether they are in favor of planting a community garden at school. Of the 96 boys surveyed, 61 are in favor, and of the 88 girls surveyed, 17 are against planting a community garden. So the first task is to go ahead and create your frequency table. So again, think about the two variables that you're talking about. You're talking about boys and girls. And this example was taken out of our text, so you might see it in there, the big ideas text. And then they're asking you about a community garden. So basically what they're asking you is, do you want it? Are you in favor of it, or are you not? So it might help. And if you look in big ideas, they generally put a title kind of at the top. So this represents community garden. This would represent gender. All right. So then I'm just going to kind of fill in the data with what we have. It says of the 96 boys surveyed. So that means there was a total of 96 boys. So that has to go in this column over here. So all of this, or actually this row. So this row represents all the boys. So there's a row, this total is 96. 61 are in favor. So 61 said yes, which then implies that we could do some subtraction here and figure out that 35 said no. The next one says of the 88 girls surveyed, so 88 girls, so again, row, total is 88. They said that 17 are against it, so that would be in the no column. And that means if we subtracted that, we would find out that 71 were in favor. So I'm going to go ahead and finish this total column. So we got the ones over here. I'm going to add those up and I get 132. And I'm going to add up this no column here and I get 52. And now remember, this column and this row should all add up to the same number. And so we should get 184. So basically what that's telling us is there's 184 people in our survey. All right, so that's a two-way table. Next, what they're going to ask us to do is to create a two-way table that shows the joint and marginal frequencies. So what this means is a joint relative frequency, and the key word here is relative, and the marginal relative frequency. So what they want you to do is a little math, which is great because that's what we like to do, right? So what we're going to do is a joint relative frequency is a fraction, and then what you do is you take the joint frequency and you divide it by the total. So for example, I would take like 61 as a joint frequency because it represents boys who like the garden, and I would divide it by 184. A marginal relative frequency is the ratio or a fraction of the marginal frequencies. So remember, there are four marginal frequencies here: 96, 88, 52, and 132. And to get the relative frequency, you just have to divide it by the total. So this is what they mean by go ahead and create a two-way table and just put in the joint or relative marginal frequencies. So I'm going to go ahead and construct my table again. So boys, girls, yes, no. And so what I'm going to do is I'm going to go ahead and fill in these numbers. So I'm going to take 61 and divide it by 184 because it's 61 over a total of 184. And so I get 0.332. And then I'm going to do that for all of my numbers within here. So I get 35 over 184, and I'm going to write it as 0.190. I'm just rounding to 3 decimal places. For the girls, I'm going to take 71 out of the total, and I'm going to get 0.386. And then for the girls that said no, it's going to be 52 out of 184. And I get 0.092. those would be all your your joint relative frequencies, because all of those had to deal with a joint frequency over the total. If you want your marginal frequencies, I'm going to add onto my table here, you would need to take the total. So you'd take 96. So 96 is the total of that row over the total in the whole survey. So 96 over 184 is 0.522. That's a marginal frequency, marginal relative frequency. So for this one, I would take 88, because that's the total of girls, over 184, and I would get 0.478. And then over here for yes, basically for those who agree with the community garden, I would take 132 divided by 184 and get 0.717. And then for this one, I would take 52 over 184 and get 0.283. Now remember, all of this and this, since these are now relative frequencies, what they're basically talking about is like a percentage. So if we change this into like 52% or 48%, you know, what they're basically saying is this all has to add up to 100. Since I wrote it as a decimal, we're going to add those up to 1. If I wrote it as a percent, this would be 100%. So this would be your table if you're asking to do a table of joint relative frequencies, that's the green, and marginal relative frequencies, which is going to be the pink. All right, conditional relative frequency. And so what a conditional relative frequency is really just a ratio, so again, just a fraction, of a joint frequency divided by a marginal frequency. So rather than dividing it by the total, we're just going to kind of look, and I'm going to kind of go back to this page right here. So we're going to look and say a joint frequency like 61, and instead of taking it out of the total number of people in the survey, we're going to take it out of the total number of boys. So like it would be like 61 out of 96. Or if I did, you know, the number of girls or the number of people who said yes, you know, 71 girls out of 132 people in the survey who said yes were girls. So let me show you a couple examples. So it says, what is the probability that a randomly selected boy would not be in favor of the community garden? So the first catch here is that it's a randomly selected boy. So that means we're not talking about the total of the whole survey. We're just talking about the total. We're just talking about the total of boys. So in this survey, I know I have 96 boys. So that's your marginal frequency. And it says how many are, what's the probability that they're going to be in favor, would not be in favor of a community garden. So that means 35 would not be in favor out of 96. So a joint over a marginal. So then my probability, I would take 35 divided by 96, and I get 0.365. If I wrote it as a percent, it would be about 36.5%. So 36.5% of the boys are not in favor of having a community garden. Next question, last question says, what's the probability of a randomly selected person who agrees with planting a community garden is also a girl? So we're saying, okay, look at the people who said that yes, they like the community garden. So what we're talking about here is the sum of this, of this row here. So of all the people that said yes, they would like a community garden, what is the probability that that person, if we just chose out of this people, what's the probability that person we chose is a girl? So that'd be 71 out of 132. So my conditional frequency, again, because it's a joint over a marginal, 71 divided by 132 is 0.538, which is approximately 53.8%. So 53.8% of the people who said yes, they like a community garden, happen to be girls. So that would be what we can call a conditional relative frequency. All right. Well, good luck with the homework. Make sure you check in with your teacher during office hours if you have any questions, or feel free to email. All right. Bye, guys.